All right. Next up, we have Aysin and Arthur from Fyndiq. Give them a warm applause. Round of applause.
Hello, thanks for being here and listening us and sparing your time for it. Not that you have another option. So what we want to share today, Arthur and me, our findings, moving our monolithic application to Google Cloud. We are still having some struggles and we are still having some problems, but we have come so far and we wanted to share the details. Unfortunately, we don't have so much time to actually go into coding details or super interesting parts. So if you have any questions, you can find us because we have a booth on the corner. So I'm just want to give you a brief agenda. We're going to talk a bit about ourselves. Am I too loud? Is it? No? Okay. About Fyndiq, we want to talk about monoliths, our problem solutions, and the Google Cloud Platform. We will have a short Q&A. Well, we were supposed to have a winner for the Fyndiq game. We had it on our corner, but I think not so many people attended, so sorry. So who we are, my name is Aysin. I'm from Turkey. I studied in San Francisco. I'm dropped out from the college. I love Python, and it got me my job where I am right now. And I've been a backend developer for 2 years now, and just switched to DevOps team recently because I have very high interest in the cloud platforms and how the storage works.
Yeah, and my name is Arthur. Also, I started at Fyndiq 3 years ago. 2 years I worked as a software engineer, backend, and then I switched to DevOps. So we formed a new DevOps team. And yeah, I've been working with Python for 10 years now. Started using Django in 2007. Made a contribution, which is mainly removing the Borg design pattern.
Which was announced earlier, by the way.
Yeah,
I think he's not here anymore.
Good.
Yeah,
good.
okay. Okay, so what is Fyndiq? Fyndiq was founded in 2011 by 5 founders. One of our founders, Frederick, ordered a lot of Vietnamese vases from Southeast Asia, but he couldn't sell it. And he was asking himself, well, there should be an easy way to actually sell good quality products for cheap. And they founded Fyndiq. Right now we have around 17,000 merchants from Europe and from Sweden mainly selling their products, and we have about 1 million. And our orders goes from 5K to 10K, 15K, depending on the seasons. And we're about 73 people in the company right now. So this is our desktop site, which is running on Django and Fyndiq. And I'm sorry, Django and Python, not Fyndiq. So, and this is our mobile application. This is also tightly coupled with our Monolith. We just released our shopping app, which is running completely on cloud, but we have an API that is updating our Monolith as well. So why do we want to share this, our finding with you guys? Because, I mean, we have been, at Fyndiq, all the developers trying to have worked really hard to actually successfully achieve our deployment to cloud. But we realized it would have been a lot easier if there were out some information, how other people did it. So we would just want to fill you guys in it too. So our main problem was scalability, deployment, and hardware management. But before going into our problems, I want to briefly talk about our monolith. I mean, how many people worked on the monolith before? Okay, unfortunately, everybody. Yeah. So I'm anyway going to say what monolith is. It's a component. It's a one big container where all the components tightly coupled. So as your monolith grows, it's really hard to become splitting apart. Right now, we tried this, trying to split up our monolith. By the way, this is how our models looks like. I don't think it looks really good right now, but we have our product model is here, and our order model, it's super tightly connected. Unfortunately, breaking apart them was taking a lot of time, so we have a designated team of 3 people. They are working on this now, on the side of while we are maintaining the business. And yeah, we have 75,000 lines of code, right? Yeah, and we have 12 servers running. Okay, and I wanted to give you guys very brief overlook of our platform. So when the client request comes in, we have Nginx as a web server, and we have HA proxy as a load balancer. And our monolithic application is Django with Python, and we have front-end languages as well. We use Celery for messaging queue, and RabbitMQ as a broker, which updates the database and Elastic, Redis, etc. We are successfully achieved of splitting 3 services right now. We have the payment service, we're using Klarna. I hope I'm okay to say this. Yeah, Klarna checkout, yeah. That's on the service, and these services all running on the cloud, and it's automatic deployment. Anyways, Arthur is gonna fill in later. Okay. I mainly work on the merchant analytics, and that was my first project when I get to explore Dockerize our project, the application, use Kubernetes and container engine. Afterwards, it was a lot easier for front-enders to actually make deployments, continuous deployment. And that's when we realized the advantage of having microservices on cloud running. Okay, and our monitoring tool is Kibana, Sentry, and Datadog. I love all of them. And I know there's a company here sponsoring their also monitoring tool. I promise to check that out as well. But Datadog is my main tool that I really enjoy seeing overall platform, because you can see when you have a high load on the database, or if you see that RabbitMQ is not responding, or use key is overloaded, or you have some issue with Nginx, or anything like that. It's really nice to see the tool, your issues. We use version controlling, GitHub, and Circle CI for continuous integration. So the problem is scalability. What we do right now, we have 9 web server running, and we have monolith instance running in each of them. So when we want to, at one point, there are some ex-Finnians here who knows this story maybe. We wanted to go to Germany, so we purchased a lot more servers, and we scaled it horizontally, running monolith instance, each of them. So we are right now 3 DevOps in the team, no sysadmin. So what we are thinking, if we purchase another server, that means one of us have to spend time configuring this monolith, making sure the other interflux, that's what we call our servers, servers are aligned and it's working fine, which is time consuming, and we don't want to spend time on this. And another thing, you can see this is our order view daily, and the screenshot was taken from Datadog. Yeah. So you can see around 3 o'clock, strangely, some people are shopping 3 in the morning. We don't know who. But around this time, we don't want to run 9 web server. I mean, there is no point of us paying this money. And our main load starts actually around 1 o'clock. And from there to 22, we are okay to pay this money, but why pay during this period? So this was another question came up to our mind. Of course, Finnic experience seasonal traffic means if you work in e-commerce, you know that Black Friday, Christmas, New Year's, you get a lot more traffic in. So you need to we want to give a little bit more flexibility so we can run 2 more services if it's necessary. And I wanted to share this Datadog view. In here, you guys can see we are keep tracking the queries on our database. And we have read and write. No, write and read. No, write and read, sorry. And I mean, our read queries are 10 times more than write ones. So this was another problem that we were facing, and we want to be able to scale our replicas as we move forward. And also the storage-wise, we want to have something scalability, means for the storing the files. We purchased 8 terabyte hard drive, and we are not even using 70% of it. So we asked ourselves this question, why even purchasing that much of it if you're not using, why waste money? And besides money, why do we need to maintain this hard drive there is no point of it? So we want to have something scalable storage. Another issue that we've been facing is the deployment. Right now, we have really good bash script running, for deployment, but unfortunately, we have to edit this bash script as we move forward. So the first thing, we are doing the deployment manually from our computer. If you're connected to Wi-Fi, you're screwed. Sorry for my language, but so you lost connection and you need to do deployment again. And our deployment takes around 13 minutes. And another thing that we discovered, actually, Arthur will mention later, we tested cloud storage. And in cloud storage, also in our bash script, we are running collect static to collect the media files, static files. And you need to upload this to cloud. So every time we're running the deployment, for each server this collect static was running. So our deployment went from 15, 20 minutes to 30 minutes. So we had to actually edit our bash script and share this whole file across the interflux. A little bit hack there. Yep. Also, the next one is the hardware management. As I mentioned, we are just three DevOps people in a DevOps team. And Arthur is actually working in a new platform, another person is a cloud engineer, and I just newly started. So there is no room for us to actually maintain the hardware. And actually, I want to share a funny story. I'm not going to give who is our server provider. One day we come to office, everything is going great. Around noon, where our peak time starts, site went down. And we were like, okay, let's check the monitoring tools, what's happening, and we can't find anything, and there's no one is deploying. And okay, one of our sysadmin, he's very relaxed. He's, don't worry, I will just call our server provider, because they were doing some maintenance. So we called them up and saying, hey, what's up? Is everything okay? Because we're not able to reach the site. They're like, oh yeah, nothing, no problem. Your server's all good. So we hang up the phone. 5 minutes later, they're calling us. Oh, okay. So there was a technical issue. We forget to plug your servers back in. Okay, great. So our sysadmin is going crazy. This really cool, calm Swedish guy, he's on the phone going nuts. How can you do this? So, I mean, and I think there's another story. Do you want to share? The server product is fun.
Yeah, the other story is basically hard drive failure. So what happened is hard drives were really slow, like barely running, and we called the server provider also. So what they did, okay, we can switch the hard drive, but we don't know which one. So they didn't know where the hard drive was actually located. So they gave us software. They gave us a small program to run on the server. And what that program was doing, it blinks an LED on the hard drive. So we installed this program, and the LED blinks. We call them. It's like, yeah, it's running now. So they go into the server room. Yeah, now we know.
Yeah.
So.
Yeah, exactly. I mean, we don't want to deal with this kind of stuff. I mean, it's kind of fun afterwards, but during that process, it's very stressful. I mean, also we are 2.5 now DevOps members. So, I mean, we don't want to manage all these servers. We have some more servers. It's not just 12. And the other thing is the cost. I mean, in Google Cloud Platform, you're not really able to say how much you're going to pay because it's all dependent on the CPU usage and all the other services that you're using. But right now, we made a basic calculation in our team. Us running all these services and not being used, the whole capacity, it's costing us a lot more. I mean, I'm not even considering that we are trying to look for some extra DevOps people to come in and actually maintain this stuff. You're going to pay for the extra DevOps person, the salary, and now you have to maintain this hardwares, pay for it. There's a lot of problems. So we just don't want to deal with this stuff. So our solution was to actually, first of all, scale. How? We want to Dockerize we have Dockerized our monolith. We had some issues, which Arthur will mention later in detail, but we want to use Docker and Kubernetes because the Kubernetes enables you to easy deployment. And we want to use everything on Google Cloud Platform. I mean, why just Cloud Platform and Google Cloud Platform, not Amazon? Because Amazon is also a marketplace, and we felt kind of not secure to put all our data in that kind of platform. So we picked Google Cloud. And in Google Cloud, we are using a lot of the services they're providing, actually. To begin with, our data team is using BigQuery and PubSub to analyze some data. They recently started working on this too. But us in the DevOps and backend team, we are using Cloud Platform, Container Engine, and Cloud SQL. So to give you guys a quick overview is what this Google Container Engine is. Google Container Engine is this super cool tool that you will love to use, which is, I'm sorry, Google is not paying, by the way, for this, which they should. It's come with pre-install managed Kubernetes. And it makes deployment super easy for you. Cloud storage we wanted to use for our media and static files. And also then we realized, why don't we use for other like product images and etc. We have a lot more files that we need to store. That's why we picked the cloud storage. And then we don't have to pay we don't need to buy 8 terabyte hard drive and just use the 30% of it. So we can scale the storage as we need it. And the last but not least will be the Cloud SQL. We are using it because it comes with Managed MySQL. That's our database choice right now. And again, it's easily scalable. So we don't have to worry about, we need to have more read replicas than write. And it will reduce, of course, the work of hardware management. That's about it. That's my picture, by the way. Arthur drew. I wanted to share with you guys. And now Arthur will take over, and he's going to explain more in detail.
Exactly. So this is the slide where we switch.
Yeah.
I just want to share a few tips. So while implementing Google Cloud Platform in our Django Monolith, we discovered some problems, and just want to share some tips. If anybody else wants to do this too, they can find this hopefully very helpful. So the first thing I want to mention is that how do you separate the different environments in Google Cloud? So there are different options. You can use projects to have separate projects. You can use in Kubernetes namespaces. You can also use different clusters. But ultimately, we settled for having 2 different projects. One's for devs, one is for production. In dev project, it's mainly for developers to play around with. So they can on their laptop develop, deploy Kubernetes stuff, and just try it out. Once this is done, if it's correctly working, they can contact DevOps, and we will go through some checklists and make sure it's correct, and then deploy it. So one helpful tip is to have a small wrapper script around these 4 commands. I noticed I typed this in a lot. Just to switch between those projects. So sometimes on your laptop you're trying to get all the stuff running in dev, sometimes in prod. So it's save yourself some typing time. And actually it turned out to be a really good decision. We had this case where a developer just deployed something to dev project and it used all the resources, 100% CPU. And we're really glad we made this decision. It didn't affect production. Some tips around building the Docker image. So we divided this into different steps. So the first step is development environment. The second one is the CI environment. Third one is production. That's where we're at. And the next step would be Kubernetes. It kind of runs, but it's not tested very well. About the development environment, we use Docker Compose. It's pretty easy to start. You have a YAML file, and in that file you can specify all the services that you have. It's easy for developers to work with. There are pretty good images available on Docker Hub already for the different services like MySQL or RabbitMQ. So you don't have to really build everything from scratch. The main tip that I have here is kind of to upload all the images to your own registry. Google Cloud comes with a container registry, so you're not relying on Docker Hub. So this happened to us with Datadog actually. So at some point they removed some tagged image from the registry, and we couldn't deploy it anymore. So that's always a good thing to have. And another thing we noticed is the Django run server is causing problems on Docker for Mac. And we have, I'm not sure, half the developers develop on Mac. This is an example Docker Compose file. Very simple, just to show it a bit. This database in web, and you can just type Docker Compose up, work on it, and type Docker Compose down. The Django run server problem is mainly because of the polling of the file system. So Docker for Mac implements OS X FS file system, which is pretty bad performance. And the Django run server just constantly polls the file system for changes. So if you use Django, the run server is basically auto-reloading. So once you make a change, it automatically reloads the server, and you can basically keep developing or keep viewing it in the browser. So this is a pretty big problem with Docker for Mac. It used a lot of CPU, a lot of, you could hear the laptops of people running this. It used like 100% CPU constantly. So the workaround that we have for that is to use Run Server Plus from Django Extensions app. And the benefit of this is that it uses Werkzeug, and Werkzeug uses Watchdog. And Watchdog can, instead of polling the file system all the time, it will just it will use file system events. It means if a file changes, the file system will notify the run server and reload. So this brought CPU usage down a lot, and it's pretty easy to implement in the compose file. So there's another fix that was done recently, which is volume. Forgot the cache consistency in Docker. One of the last versions. I haven't tried it out yet, but it should also fix this issue. Container registry is basically a private registry for your Docker images that you get on Google Cloud. And so it's pretty easy to log in. You use the Google Cloud SDK. You type login, it will start a browser. You can just review everything and allow it. Building images, the main part is that you need to include this gcr.io / and then your project name, Google project name. So that's how Docker knows that where to push the Docker image. If you don't specify this, it will push to Docker Hub by default. And there's this wrapper around Docker. You can use gcloud docker, which is basically the Docker command wrapped in gcloud with authentication. So you can if you just use docker push so-and-so to your private registry, it's not authenticated. It wouldn't work. If you use gcloud docker, it's authenticated with your library, and it works fine. You can also use gcloud docker-a to get short-lived access. And this basically gives also authentication, but short-lived. And you need this for Docker Compose if you have private images in your Compose file. So we have a few of those. So you need to be authenticated. Circle CI problems. Circle CI version 1 uses a pretty old Django Docker version. The problem is that they use 1.9, which is before the current versioning scheme. I don't know from when it is, but it's patched. The server version is some 1.9 Circle CI workaround. Compose is not supported on it, so you kind of have to run the Docker run stuff manually for all your services. And recently they released Circle CI version 2. Problem with version 2 is that everything runs in a Docker container, so you build Docker containers in a Docker container, and which is okay. I mean, you connect to a remote daemon. The problem is that you cannot have volumes. Volume mounting doesn't work in there, so that's why I'm holding back a bit with this. It requires a bit more work to update. And then main part is that CI pushes to container registry, and to do this you use like a service account key, which is like API token. It's a file you say activate service account, and that means that the gcloud SDK has access to your project. Another tip is to use Circle CI has a Cloud SDK pre-installed, but it might have an old So Cloud SDK comes with kubectl, which is or kube control, which is used to communicate with Kubernetes on Container Engine. The problem is that the versions might differ. So it's always a good practice to update the Cloud SDK that has the kubectl version matching your cluster running. 5 minutes? Oh man, okay, I will make it a bit faster. So Container Engine is a pre-installed and managed Kubernetes cluster. Latest version is usually available, so Kubernetes is installed by Google, developed by Google, and usually that's why it's so fast available on Container Engine. The main point I want to say here is that Kubernetes consists of a master and several nodes. Google auto-updates the master for you, very kind of them. But the nodes, they have auto-upgrades. It's not recommended. It might break. The point here is that eventually you will have to update your nodes. They cannot, if there are more than 2 versions behind the master node, there might be some incompatibilities. So you can, you're kind of forced once in a while to update. We found this project structure to be very useful. You can just run kubectl apply and then point to the dev folder or point to the prod folder. It's very easy. It does rolling updates. It would solve our deployment problem. Kind of. This is another tip that we had. In Docker, the latest tag is like a special tag. It kind of means pull the latest version. In Kubernetes, it's not. It's just another name. So if you come from Docker thinking to this thinking, you might say, okay, kubectl apply this, but the first time it will work, the second time it will not work, because Kubernetes will recognize, okay, I'm already running this latest image. Why should I again deploy the image latest, named latest? So what we do is just run this set command that replaces the image with the current git SHA-1. And then apply. So we use the git SHA-1 as a version. Cloud storage, 2 minutes? Okay. Okay, good. Cloud storage is what Aysin said, basically. Django has a storage backend. It's easy to replace. Default is file system backend. And you can easily use Django storages library. It comes with the Google Cloud backend, also Amazon backend if you want to use that. We use some third-party libraries which work fine with Django storages. You have to set the the default storage variable to use this new backend. If you have used the Django default models file field, it will automatically pick up the backend. We'll skip this. I have examples of using Django compressor, static files. These are Django templates. We just wanted to include them for people who don't know Django so much. I'll skip them now. Okay. This is the main part, kind of assumed in our code that we will always use file system, but it proved to be a wrong decision, kind of. So the right way I would do it now is to always use the storage system. They don't have a context processor, so we use. You have to use this way. File names. In storage, they don't have a directory structure. Everything is an object, but you can include slashes in your file name. The problem is that they will be encoded. One problem we encountered is in Django admin. In their CSS files, they use relative paths. So if the base CSS has points to a relative path up, 2 dots up, 1 folder up, to foo.png, it will not work. So in this example, the admin until CSS is one file name, so it will go to the top directory. So we'll have to somehow replace this and convert it back to slashes. So when it renders the template, it will automatically, or not automatically, but like pick it up properly. This is a big thing, kind of, if you use Google Cloud Storage, it will, if you want to use your own custom domain name, like storage.finnic.com, it will not work with HTTPS. It's not supported. If you want to have HTTPS, you will have to use the Google APIs.com URLs. I have Cloud SQL. You can use Django also for that. It's just another Django instance. We use Django replicated. It's a database router who splits up the database queries. This is another, you need to have SSL certs, and you can do it like this in Django. This is my main problem with Cloud SQL. It's Django, Google will automatically update your cluster for you and restart it whenever they want. So I cannot really recommend it for business critical things. It's, you can pick a maintenance time though, so they will respect that. Okay, thank you.
Do we have time for question?
Maybe one question.
Okay, one. Who is our favorite person in the audience?
Okay.
No one? Any Indian wants to ask question? No? Okay.
For dev, do you always use work inside Docker, or do you also use directly maybe in a virtual env for kind of convenience or performance?
Yeah. To answer short, most developers use virtual env.
Yeah.
So we try to use Docker for everything. Let's use Docker for everything. But a lot of developers don't like it. It's too complicated. It's you constantly type Docker run, blah, 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 and more complicated it should be. So a lot of people just run all the services, MySQL and so on in Docker in the background, and then they develop the Python code in virtual env and connect it that way. That's how it resulted in.
Thank you.
Okay. Yep. Thanks for listening.
Thanks.